Good morning. So today we will have a discussion on congestion control algorithm. So first we will try to understand what do you mean by congestion, and then why it need to be controlled. Okay, and then how it has to be controlled. Okay. So what is congestion actually? Congestion means when too many packets or too many people will stand and then will try to move, but they can't move there. So there, what happens? The congestion takes place. For example, in bus, many people will be there, and then you can't able to move. Okay, why? Because of that congestion. Now here, when too many packets are present in the subnet, say there are too many packets in the subnet, this will degrade the performance of the subnet. I have taken an example here of the subnet where so many packets are there. Okay. Now, due to many packets, the performance of the subnet is going to degrade. So this is a situation where the performance degrades due to many packets is what called as congestion. Okay. So this is what called as congestion. Now, when the number of packets dumped means when it is sent into the subnet by the hosts, when it is sent into the subnets, this is what called as dumping. Okay. Within this, if the capacity is less, carrying capacity of the channel, if it is less, then what happens? The traffic arises. Okay. When there is heavy traffic, then the congestion arises. If the capacity is more than the number of packets what you are sending, then the destination will receive all the packets. Okay, let us try to understand the congestion. For example, A will send a frame to B. Okay, I have differentiated by different colors here, and F also sends a frame to B. Similarly, E sends a frame to B. D also sends a frame to B. Now, B has to transmit it on C line. Okay. Here, this it has sent, this also it has sent, this also it has sent, and this also it has sent. Now, all the packets need to be sent on this same line, that is from B to C. Now, what happens? All the packets need to be stored and then forwarded from the routers. So to do this, a particular time is required. When the packets are still storing and then need to be forwarded, other packets will arrive and then traffic is going to occur here. Okay, this leads to congestion. If one more packet is going to arrive, how it has to go? It has to pass this all the packets. Due to this, the congestion occurs. Okay, this is what called as congestion. When too many packets are present in the subnet, the performance of the subnet is going to degrade. This situation is what called as congestion. Okay. Now, let us see the general principles of congestion control. Now, this need to be controlled, else congestion need to be controlled. Else what happens? The packets will be lost. Okay. If congestion is going to occur, then packets it will be losing. So we need to control this congestion. So what are the general principles of controlling this congestion? That is congestion control. Now there are two methods to control the congestion. That is congestion control. We are having two methods. One is open loop method and another one is closed loop method. Okay. Now first we will try to understand when it is called as open loop and when it is called as closed loop. Okay. First, open loop. Okay. Now open loop solutions we are going to attempt means congestion we are going to avoid or else we are going to control. In case of open loop, well in advance, the designing is done so that the congestion is avoided. Okay, in open loop, we are avoiding the congestion before it occurs. Okay, we are going to avoid the congestion in case of open loop. Now here, how we can avoid by means of a good design. Okay, how we are going to design the subnet is the congestion doesn't occurs. Okay, means first itself we are avoiding the congestion before we start transmitting our packets in the frame. But once the packet is sent, means once the packet starts running, in the middle we cannot correct. In this method, if already the packets are sent and we need to control the congestion, then it is not possible, because first itself the designing is done to avoid. How we can avoid? That is, we can see the traffic and then we can send the data. Okay, that is one method. Okay, and then we can have a timer where slowly we can transmit the data. So like this we can avoid the congestion. If we are avoiding, then it is what called as open loop method. Now in the closed loop method, now congestion may occur during the runtime. That is when the packets are sent in the subnet, then chances are there that the packets may get collided, or else the traffic may occur and then congestion takes place. Okay, so in that case, we need to have the congestion control during runtime. Okay, during runtime. What is the meaning of during runtime? Is when the packets are sent, and later congestion takes place. Okay, in that case, it is what called as closed loop. In that case, it is called as closed loop. Okay, now here what is done, how we can control this is when the packets are sent and congestion occurs, a feedback is taken, that is feedback loop. It is based on the concept called as feedback loop. It is going to feedback that the congestion has occurred and we have to avoid this congestion. That can be done by a method called as choke packet. Okay, whereas open loop we are having a method called as leaky bucket. Okay, in open loop we are having leaky bucket method. In closed loop you can think of the method is choke packet. Okay, so here during runtime, what all things we need to consider? There are three approaches, or else there are three parts which the closed loop should address. First thing is monitor the system to detect when and where congestion occurs. Okay, means we have to monitor where the congestion is getting uh, placed, or else where it has been occurred, or else when the congestion may occur. So that we have to monitor and then we have to detect it. Then second thing is pass this information to the places where action has been taken place. For example, if the congestion has occurred at this place, then during runtime, if it is closed loop, then this we are going to send to rest all routers or else stations, so that they can slow down the sending of the packets. Okay, they can slow down, or else even for few minutes it can be stopped. Few time interval, let us say t milliseconds, it is going to stop sending the data. Okay, so that is what why we are going to pass this information to the places where actions can be taken place. Where actions can be taken place? At the other routers. Now, third point is adjust system operation to the correct problem. Now, address that problem where the congestion has occurred. Okay. Now, let us see leaky bucket algorithm. Leaky bucket algorithm. It is open method, open loop method. One of the example of open loop method is leaky bucket algorithm. Let us try to understand leaky bucket algorithm by means of a practical approach. This everyone knows. Say there is a tap, there is a bucket here, which it is leaky, means at the bottom there is a hole. Now, when this tap is closed and there is no water, then it will not leak. Okay, it is not going to leak because water is not there. Water is not there. Now here, when we start this tap faucet, then water starts filling in this bucket. As there is a what leak here, so the water starts pouring out. Okay. Now it is not dependent on how fast the water is coming in, means how the flow is. Rather, here the flow will be constant, drop wise. Drop by drop it will be going, means it is at the constant rate. The flow, outflow will be in constant rate. Okay. Now, if the tap uh, pours more water, then automatically what happens? The bucket will become full because here the rate is slower than this rate. Then automatically what happens? The water, after filling this bucket, it is going to overflow. It is going to pour out. Okay. This is what the practical example. Now the same example we can compare it with our leaky bucket algorithm. What happens and how it is going to work. Okay. Now here there is empty bucket and there is a hole here. Now when no packets are coming in, so no packets will go out. Okay, no packets will go out. When the packets are coming in, then it will start transmitting with a constant rate, with a fixed rate. If the packets which are coming in are more, okay, such that the bucket becomes full, then it starts losing these packets. The packets which are coming in after this bucket becomes full will be lost. Okay? Whereas from here, there will be a continuous flow. This is what happens in the leaky bucket. Now, leaky bucket follows these steps. Okay, we'll see one by one. Each host is connected to the network by an interface containing a leaky bucket. Means if there are 4 hosts which we have, which they have been connected to a common channel, there are 4 hosts like this, where they have been connected to a common channel like this. Okay, channel is common, means all are connected to this. Now here there will be a buffer where it will store and then forward, which is called as our interface. It is called as interface. Interface. Okay, interface containing the leaky bucket. Okay. Now here means each host is connected to the network by an interface containing this leaky bucket. Now, second step is when the host sends a packet, then this packet first enters the bucket. Means whenever a host sends the packet, it first enters this interface, leaky bucket. Then it will be forwarded. Okay. Now, next thing is the outflow of the bucket will always be at a constant rate. Means whatever outflow it is there, it will be at constant rate. means per second how many packets it is sending, always it will send with the same rate. Okay, for example, in 1 second, if output is 4 packets, then next 1 second, means next 1 second again it will send 4 packets of the same size. Okay, that is what constant rate. Now if no packets are sent from the host, if no packets are sent from the host, means what? Bucket is empty. Bucket is empty. Then no outflow from the bucket. Then there will be no outflow from the bucket because bucket is empty. Now, if packets are sent such that the bucket is not full, but host is sending the packets, then the packets will flow with a constant rate. Here, constant rate. If the packets are sent when the bucket is full, the packets are sent when the bucket is already full here, then the additional whatever packets are coming in, sent from the host will spill over and will be lost. Spill over and will be lost. Okay. Now this we can able to see here also. There is a host computer. Here it is unregulated flow, means it is not at the constant pace. Host may send 2 packets, then once it may send 3 packets, once it may send 5 packets. It is not constant. It keeps on sending here. That is unregulated flow. First, it reaches the bucket here. It holds the packets. Then it is going to send it in a regulated flow to the network. Okay. Now this method burst the traffic is converted to an uniform traffic, means your bursted traffic is converted to uniform traffic. Okay. The interface containing the leaky bucket contains finite queue, means there is a fixed queue, fixed output rate. Okay, 4 packets per second, means always it will be 4 packets per second. So there is a finite rate. Okay. Now this is what one thing, that is we can have interface containing a leaky bucket. But at the host computer, we can still avoid this congestion. One thing is in the channel, how to control, we have seen. That is, we can have an interface where it stores the packets and then forwards it using a regulated flow. Okay. But at the host itself, we can have this control, that is congestion control. Still, the congestion can be avoided by considering the following steps. So what are the following steps? The host is allowed to put 1 packet per clock tick. Okay, it might be 1 second, 1 millisecond, so that can be considered as 1 tick. 1 tick. So that is what called as clock tick. So now what it has to do? Host computer has to send 1 packet per clock tick. Okay, means if it is, I'm fixing it for 1 millisecond, means after each 1 millisecond, 1 packet has to be sent from the host. This we can fix at the host level itself. Okay. By doing so, we are reducing the uneven flow. Here there is uneven flow. 2 packets, 3 packets, you can consider 5 packets. Okay. That uneven flow, we can convert it to an even flow from the host itself. Even number of packets will be flown by considering it in the form of clock. Okay. Next thing is, at the host, what we can do is we can have same size of packets. We can have same size of packets. Means host has to send same size of packets. If I consider 8 bits 1 packet, so 8 bits 1 packet, all should be of the same size. This is one method. Okay. If host sends same size of packets, then it will be easy to send on the outflow because size is same. So outflow will be same. Okay. Now, if say the packet size is uneven, packet size is uneven, it is not the same. If the size of the packets are not same, then also we can make it uniform. Half, that is by using fixed number of bytes per tick. Tick will be same, that is 1 milliseconds. As per our example, in 1 milliseconds, we can fix the number of bytes. How many number of bytes we can send, that we can fix it here. For example, if the rule is per tick, means per milliseconds, as per our example, 1024 bytes will be transmitted. This is what rule we have fixed it at the host level. Okay. Now, packet size, if it is 1024, what we are considering here, packet size is uneven. If packet size is uneven, then still how we can send a even form of packets is by this method. Now here what I have considered is, I have considered a rule that I have to send 1024 bytes per tick. Okay. Now say first case, I'm considering it as there is one packet. Okay. Size is 1024. Only one packet, size is 1024. Then in that case, my fixed per tick is 1024 and my packet also it is of 1024, means only one packet I can send in that one tick. In that 1 millisecond, I can send only one packet. Okay. Now 1024 bytes, packet size is 1024 bytes, then only one packet I can send. Let us consider that my packet size is 512, that is 512 bytes. Packet size is 512 bytes. Now my rule is what? I can send 1024 bytes per tick. So how many packets I can send? My each packet size is 512 bytes. So now I can send two packets in one tick in 1 millisecond. In 1 millisecond, 1 millisecond, I can send two packets. Okay. Now, similarly, if we are having 256 bytes, 256 bytes, then I can able to send four packets. I can able to send four packets because 256 plus 256 plus 256 plus 256, 4. If I add, then I'll be getting 1024. 512, 2 packets, then it will be 1024. Means here I can able to send 4 packets will be sent per day. So this will avoid further congestion. Means at the host level, we can avoid the congestion. Okay. And in the channel, we can avoid by means of interface containing a leaky bucket. Yeah. So this is how we can control the packets. Now, if the packet size, say it is greater than 256, like it is 400. So 400 plus 400 plus 400 will lead to how much? If the packet size is, say, packet size, if my packet size is 400 bytes, now if I consider it as 400, one packet plus 400, it is 800 now. Okay. still my level is still 1024. Okay, if I try to add still more 400, then it will become 1200. So in that case, I have to send only 2 packets. Okay, in this case, I have to send only 2 packets, and the third packet has to wait. I have to send only 2 packets from the host. We have to wait for another tick. Means when other 1 millisecond time is going to occur, then the third packet is sent. So this is how the leaky bucket algorithm works. Okay, so I'll just brief out the things what all we have just studied. Leaky bucket. So here we should have an interface. Then how this interface is going to act, uneven flow, then it is going to convert it to regulated flow. How it is going to convert all those things? If packets are not there, no packets will be sent. If packets are coming in, first it will store and then sends it with a fixed rate. If the bucket becomes full, that is storage buffer becomes full, then automatically it is going to spill out and then it is going to lose the rest all packets which will be sent from the host. This is the thing. Then this is where it is controlled in the channel during transmission here in the channel, and we can still control it by means of controlling in the host itself, transmitting of packets in the host itself. That can be done by means of having uniform packet size and to allow the host to send 1 packet per clock tick. Means packets per clock tick we can send. Okay. So this is what all regarding leaky bucket algorithm, and then how the congestion takes place, how the congestion has to be avoided. Okay. Then thank you.